So I'm going to talk today about database automation. Database automation is part of continuous delivery, is part of continuous integration. And I'm going to talk about some surveys that we had, interesting information, problems people are having, and the challenges, and of course, ideas how to overcome them. I'm the CTO and co-founder of a company called DBmaestro. DBmaestro is dealing with DevOps for the database. That's the vertical that we point our enthusiastic at. And we deal with database development and database automation. So what we're going to talk today about is the challenges around the database, getting it into traditional, let's call it automation tools, traditional processes that have been maturing, and I'll talk about that as well in the beginning, and how to tackle the challenges around it. So at the beginning, first of all, I think the most important thing to understand is that today every company is an IT company. Manufacturing shoes, machinery, doing applications. Whatever you do, you have your systems, you have your core products, and you have your supporting systems. So everybody needs to deal with application development. And as the world changes, we need to do things faster and faster. We need to be more agile, to respond quicker to customer needs, to market requirements, to competitors making their moves. So of course, we all know about agile development. We all know about the benefits from being more responsive, being able to take shorter and smaller pieces of projects and pushing them forward. And of course, that's part of what we've seen through the DevOps movement, and how to incorporate these, let's call it development benefits, into taking Agile into production, which I like to look at DevOps as part of taking Agile into production. That's of course not the exact definition. So a big part of that is just having to react quick. We can't react like saying, okay, we're going to have this in the next release, which is due in 6 months, and work in a waterfall. That's too slow. Okay, so a lot of companies are actually implementing continuous processes. Who's actually implemented the continuous processes in their company? Continuous integration, continuous delivery? Okay, cool. Who's got database as part of that process? Okay, fewer. Okay, and that's part of the thing. That's part of the challenge. So a few words about continuous integration, continuous delivery, and continuous deployment. What is it? First of all, it's not a new thing. Okay, it's something that has been around. Continuous integration has been around for a while, and it has been maturing. It is supported more and more by vendors offering tools, but it's not all about tools. Okay, it's a process. It's a process and a thought that instead of doing stuff manually and repeating it and potentially doing mistakes by manual processes, you want to automate as much as you can. So you're much more efficient, and you have a better repetitivity. So you make less mistakes if you build the process right. And the process never really ends. You fine-tune it. You find more pieces that you can improve. You find things that you can do smarter. And as the process matures, you get a more and more stable release process. So essentially, what continuous integration says is a very simple thing. We're going to trigger a process as a response to each change, essentially. You're checking in a piece of code. That piece of code is going to be validated. It's going to be built. It's going to be tested, meaning you're going to have regression testing run against that piece of code. And all of this is done automatically and very quickly. So sometimes people are implementing this as a part of a nightly build, maybe, or a process that runs from time to time. And continuous integration, really implementing the continuous part means that you have the process spawned as essentially each check-in, okay? What that means is that you're going to get a feedback to your specific changes almost immediately. If your code broke something, didn't compile, didn't go through regression testing well enough because the testing tool found some issues, or unit testing has failed some tests, you're going to get that response very quickly. And then that loop is called a feedback loop. As the quicker the feedback loop gives you the information to you and your team and your colleagues, the easier it becomes changing and improving, because you're fresh with what you just did. You're not getting the response regarding bug fixes like 2 weeks, 2 months after you did your changes. You're getting in right then, right now. Okay? So that helps bringing up the level of quality of your code, the risk of having changes, really bad changes, making their way forward. And you get great visibility for the whole process. So that's the heart of continuous integration. Continuous delivery is actually taking it to the next step. It means that you define each change as a clear packaged, let's call it feature or change. So you only check in things that are considered done. You're not checking in part of a work. And when you have that clear definition of done, that means that potentially each change that you're shipping is contained, is whole, and can potentially go all the way to production. And that gives developers and participants in the process the responsibility to make sure that their changes are really end-to-end correct, and the responsibility to make sure that they know it is potentially going to production. There's no other person potentially in that process that would say, okay, look at it again, and maybe check it. And you should have, the end developer should have the responsibility to making sure that changes will go all the way to production. And that's, of course, part of the DevOps concepts. So other than saying, okay, each change is potentially releasable, what you also have is the process to take this change forward. So you're not only going into integration environments, you're also going to testing environments and pre-production. And essentially, you can go all the way to production. And what continuous delivery says is usually that the last stage of moving to production is done manually. Okay, why manually? Because you want to control exactly when you go on to production, what changes essentially are being taken there. And you want to keep that trigger. You want to keep that trigger in somebody's hand. That makes a lot of sense to a lot of businesses, and there's no really downside to implementing this, because part of the effort, part of your efforts to implement that really improves your end-to-end overall processes, development, testing, and build. Looking at the next step, that's potentially how such a thing would look. That's an image from Wikipedia. So essentially, if you have failing processes, you would get the feedback. If not, it would go forward. Continuous deployment is something practiced by not everybody, and it's not for everybody. So it's not something you should, it's not essentially the next level, but for the ones that it makes sense, it can be also a very powerful thing, because each change is actually going all the way to production. That means that for companies like Amazon or Facebook or anybody who has a very, let's call it, potentially big audience that can do stuff like throttling traffic, maybe testing a feature on some of the traffic, saying I want to have 0.5% of the people seeing this new feature and gather the responses. That means that the application has to support both models, the new one and the old one. Okay? But when you can do that, when you can actually have something going all the way to production and get the feedback and see that it's successful, then you can throw it out and except for that A/B testing, know exactly when it's safe to issue out that feature as a generally available feature. And of course, that doesn't make sense for every operation. A bank would not probably have 2 kinds of loans, maybe yes, but for the ones that it makes sense, then it is a very powerful solution. So how do we measure success? What is a success from a continuous process point of view? Being able to do rapid changes, to react quick, being able to have better collaboration because everybody's knowing what everybody else is doing. You have a very quick feedback loop to handle changes. And essentially, you know, the end of the line is having our customers happy, delivering faster, and dealing with the competition, which, you know, we have to do it because if they're doing it and we're not, then we're behind. A survey that we recently had was talking about, you know, continuous delivery, who's actually implementing it. And what we found out is that a lot of companies, the majority of companies are now implementing continuous delivery. And that's not a surprise because the benefits are quite clear, okay? We have increased productivity. We have reduced risk. We have better quality, time to market, okay? All of these things are measurable. The interesting thing is that, I don't think it's surprising, but the interesting thing is that when you come to the database, the picture is different, okay? Only half of those who actually implemented continuous delivery for their application side are actually doing it for their database. And why is that? Let's try to understand what is the difference and what can be done about it. So essentially, the database, I would say, has been challenged for the last years regarding modern processes. Okay, we see agile development, we see continuous integration, we see continuous deployment, we see tools, IDEs, a lot of methodology going into development, but not being practiced on the database side. More than that, we see silos. We see in the same company, sometimes in adjacent rooms. We see developers working in a certain process, very mature, very sophisticated, and in the other room, DBAs or database developer dealing with a different process, doing stuff with other tools, maybe no tools, and essentially not using the best practices that are being practiced in the market. They're just lacking behind. And this is, of course, because the database is different. It requires special tooling and special attention. And the thing is that we want the database not to be the weakest link in the chain. We want this to be the strongest link in the chain because it's so important. That's our company's asset. A few interesting quotes. I won't spend a lot of time about it, but I think it talks about the challenges that people are having with the database. They're not always sure who is actually introducing changes to a specific database, a schema, okay, or any object. So if they're not sure who's introducing changes, it's harder to know what the changes are. It's harder to build a release. So you want to do your next build, you have to gather exactly what was done, what was changed. And if you're not sure, then sometimes you're lacking things. Sometimes you're moving stuff that shouldn't be moved to the next environment because it's not mature yet. It's part of an issue that was not concluded yet. It's not fixed. It's not done. Okay, so you have multiple releases. You have fixed releases. And more than that, because when you discuss traditional code development, you have a very strict and visible process. You have your development environment, you have your IDEs, you check in, you check out, everything goes into a repository, okay? Then you use that repository to issue a build, and that build gets copied, the objects from that build gets copied from one environment to the other, from the build to integration environment to QA, regression, UAT, production, whatever. But essentially, they get copied. But the database, you can't do that. You can't copy the database from QA to production. You would lose the data. Okay? That's not something you can do. You need to alter. As you all know, you need to alter the database. You need to run those scripts. But essentially, what that says is that you have full copy of your, let's call it as it is, code. Full copy of your code in each environment. And you have out-of-process changes because I was talking to a company who had a very big crisis because they had a bug. They couldn't reproduce it in development, as it happens many times. They went to QA environment. The DBA fixed it. Everything was fine. Then they shipped it to production, and everything failed miserably. And it cost them a lot of money, but because they forgot to take that fix back into development, it wasn't part of the release. So that out-of-process change was just forgotten. I see you shaking your head. But that happens. That happens. And it's hard to control. Okay? So we need to have a good process. We need to practices for the database itself. And we need to have the tooling and the concepts to support that. Because the risk of not doing it is of course, challengeable. So,
all right, girls. Now, this is your last chance. If one piece of candy gets past you and into the packing room unwrapped, you're fired.
Yes, ma'am.
Let her roll!
Oh, this is easier. Yeah, we can handle this, okay? Listen, Ethel, I think this... I think we're fighting a losing game. Here she comes.
Fine, you're doing splendidly. Speed it up a little!
okay. I think you got the message. Okay. Continuous delivery, continuous integration is here. It's not going anywhere. It is being implemented. It is being practiced. It gives good and measurable results. And the database cannot be a manual process, which is part of an automated process. Because, you know, at first, you think you can handle it. You think it's easy. Okay, you have one release maybe every couple of weeks. That's doable. When you had it, waterfall concepts every 6 months, that's manageable. But when you start spinning things up, you're having a release a day, a few releases a day, maybe more than that. There are companies who are doing hundreds of releases a day. Okay, that's not something you can handle manually. Okay, so you start up by thinking it is easy, then you find out it's hard, then you have to speed things up yet again. So database needs to be part of more mature processes because everything is going there. Okay, that's part of what's happening to the industry. And a survey that we are currently running showing that people are not yet reacting to that. They're not dealing with that. They are dealing with manual processes, manual creation of scripts, manual manipulation of environments, in order to deal with that. And of course, that's an issue. Why aren't they practicing automation? Because it's hard, you know? I see people nodding. You know, it is complicated enough to deal with these processes manually and to evaluate what needs to come in and what needs to come out. So do that automatically? How do you do that? We mapped a few sections that needs to get attention. First of all, the basis, the building blocks. The version control of the database must be managed. Then you need to deal with the way that you introduce changes from one environment to the other. If it's static scripts or tools. Then when you're taking everything to the automation side, you need to be able to control it. To have those red flags come up and say, okay, there's an issue here. Don't automate that. Don't create the damage and then decide how to deal with that. Stop before you do. Okay, so these are things that need to be considered. What many people companies are doing today are actually dealing with two separated processes. A process for version control and a process for the database. What that means is that they have their check-in, check-out essentially for scripts. And then when they need to evaluate their changes, they need to test their changes, they're going to the database, okay? And they introduce these scripts into the database, debug the application, and then when everything is good, when you're happy with that bug fix or next feature, you extract that and put it back in the version control. That makes a lot of sense, and a lot of people are working that way. But if you remember my example about the ones who forgot to take that change from QA back to development, and it was not part of the release, because that process is manual, because that process is built from different tooling, and it's not one flowing process, then you have pitfalls. And these pitfalls can catch you in awkward moments, like, did you actually take the latest script from the version control before starting to work on the database object? Not many people do so, but maybe somebody else has introduced something to that repository. Did you positively extract the script from the database once you concluded your change and put it into the version control? Sometimes people forget to do that. Maybe you started working on a database where someone was making some changes, I don't know, some testing, and did not revert his changes, and you're just picking up and building on top of something which is broken and not even working, okay? So there's a lot of challenges around that process. And these challenges are just getting into one specific problem, that you cannot 100% be certain that the repository represents your database. And that means that everything else that I'm going to talk about would be questionable from the beginning. This is something that must be solved. You need to deal with code overrides. Last thing you want to do is have two people get, I don't know, a procedure from the database to the editor. One would be introducing changes. The other one would be making his changes. The first one would check in the changes and keep his version. The other one would override, and nobody would even know that a revision was overwritten. Okay, that's dangerous. Okay, so we need to practice a controlled process, a check-in, check-out type of process for the database, exactly the way you do it for code. Okay, when we actually save revisions in our repository, what are we saving? Are we saving the change script, the alter table script? Are we saving the rollback script? Are we saving the state of the object, the definition of the object? Because if we're saving the definition of the object, we don't have the script to roll it forward. If we're saving the script to roll it forward, we don't have version control. We don't have the state of the object. So something is missing. Okay, we can't just deal with one. We need to include everything, and not many people do that. Let's say you have that script-based process going on, and you're saving your alter scripts. Then essentially you would be accumulating them. Okay, you add a column, you change a procedure, you add an index, and then when you need to go to the next environment, you would just replay them. That makes a lot of sense. In many cases, there's no issue with that. And you have another team working in parallel, doing the same things introducing their changes, and again, everything is working perfectly. But what happens, as I said, each environment has its own code. What happened if you had a hotfix to production? It went by the book through staging. It was a very urgent thing. The DBA came 4 a.m. in the morning, fixed whatever he fixed, and tested it and pushed it to production. When that next release is going to come, it's going to interact with the change database. And anything might happen. It might work fine. It might fail miserably and crash, and everybody would notice it. And worst thing, in my opinion, is it would work wrong, but nobody would notice it, and it would creep all the way to production. Again, I see people nodding because that's an issue. And that's not the only issue, out-of-process changes. Just consider teams working in parallel. One team pushed their changes from their, I don't know, branch or divisional database into the integration environment. The other team would push the same object with their changes and override that target environment. So we have unsolved issues when we discuss static scripts, because they're static and the database is not. It's not like code, which is being built on one machine and being always pushed in the same way, because code would catch these when you check them in. You have two branches working in parallel. One would check in. The other one, when he's checking in, would get a message. You have a conflict. Merge it. Okay? The database doesn't do that. It just lets you override everything. So there's a challenge. And that's essentially what I just said. So how do we solve that? How do we deal with that? The most important thing is having the building blocks in place. It needs to be a stable thing. It needs to be, like a Lego, where you stick the pieces, and they get stuck, they don't move. You want to be able to trust that. You want to have a version control process which is integrated into your database. Why would you do that? Because you don't want to have a manual process. You don't want to have to extract scripts manually. You want everything to be automatic as part of your change process. And when you do that, when you have a checking and checkout process for the database objects, then you eliminate most of the issues right there and there. Because if an object is checked out, everybody can see it. Okay? Nobody would be allowed to check it out at the same time. You would be serializing the changes, okay? And making sure that as part of the check-in process, it is being saved in the repository. So you would gain confidence in your repository. And doing so and taking it forward, essentially what you can do, all of the modern version control tools are supporting task-based development. You can associate database changes to requirements, work items, tasks, maybe trouble tickets. And when you do that, it's not just to know who was doing what, when, and why. That's the why part. It's not just that. When you're going to get to the part where you deploy things, you'll be able to say, OK, quick decision. We need to do a scope change. We just need to push out that feature and the bug fixes. The second feature is not mature enough. Performance improvements are not stable enough. Leave those behind. And you need to be able to know exactly why each change was introduced and how to push it separately. This is something that can help you, okay? And of course, when you do that version control, when you control changes, you really gain control over all of the process. So even if you have processes not going exactly by the book, dev to QA to integration to QA to pre-prod, etc., you would still be able to recognize these places and know that you need to react. So essentially, how would you do these deployments? I think you all know the build on demand type of approach. Compare and sync tools. Okay? You would look at one environment and say, OK, that's the state here. And we need to go to the next environment, integration. How do we do that? We just look at the differences. OK, there's an index here. There's no index there. Let's build it. Okay, and by doing so, you would be able to react with out-of-process changes, because when that happens, when you have an out-of-process change, the compare and sync tool would know that you need to move to a different environment. Okay, you would be able to take that into account. But you see that dotted red line. That line is there for a reason, because I don't think there's a lot of, let's call it, people who need to take responsibility for the end result that would be happy to know that you run the first, the first script to update the production database the first time. It was just created by a tool 5 minutes ago, 2 hours ago. That's risky. You didn't test that script. Okay, it's automatic. Most cases it's safe, but you didn't test it, and you're going to push it to production. That's an issue, okay? So the due process would be to run that dynamic process up to a point. Where that point is depends on you. And from that point, you would just keep the script in the repository, okay? You wouldn't want to run that for the first time on production. But when you do, when you want to take this script to production, you would need to do a validation before you run it. You would want to know that the previous version of, in that case, the staging environment is identical to what's now in production. Only if the previous version of staging is identical to production, you know that the script that was running against staging would run safely against production. Make sense? Okay, cool. So that's what you would do. So, but let's talk about compare and sync tools for a second. Everybody seen something like that for no doubt. So you see, very simple example. There's an index on, let's show them the process, an index on development, no index on production. What would you do? Probably create an index on production. Okay? Makes sense? Yeah? Sure? Safe? I think so. But if I would show you the different result, what would you say now? Are you going to drop the index from production as a part of an automated process? Maybe not, right? So looking at that, you would say, okay, maybe it was created on production by the DBA because there was some performance issues. So I'm not going to drop it. But maybe it was dropped in development. Maybe the new release has dropped that index because of performance issues on production. Maybe this is the change. Okay, so it's not clear from that response. It's not clear from this mapping. So a compare and sync tool can very easily show us the differences, but it doesn't really tell us what to do with them. And the previous example, was the index created on development, or was it dropped from production because of these performance issues? Okay, so it can help us, but we need to monitor. We need to take a decision with the result. And as a result, we can't automate it, because what would we automate? Okay, take it, leave it, depending on what. So there is a risk here. And talking to a lot of companies, they're not feeling safe pushing changes based on compare and sync automation tools forward, and that's obvious why. So essentially, compare and sync tools are unaware of anything that happened on development. They're just comparing ad hoc situation. That's what in the database now. And that's not enough to take decisions. They can deal with conflicts. What is a conflict? We'll see in a minute. And of course, as a result, they can't merge. And because they required manual inspection, they cannot be really automated. Not in a style of a process where you're trying to build a continuous process. That's not stable enough. That's not trustable enough. And that's an issue. Okay, so what we need to do, we need to take and connect these two things. The version control and the deployment cannot be separated. They need to be one thing. Okay? we need to be able to take version control information and leverage it into deployment decisions. So instead of using static scripts, okay, static scripts would work just fine until something is not as was expected and anything might happen then. If you're doing a component sync tool, using a component sync tool, then you're left with a decision which is fine, but you can't really automate that. So what we should do something which has been done for code for quite a long time now, and that's three-way analysis, or a baseline-aware analysis. What that means is that we're not just looking at our source and our target. We're also looking at the baseline at the same time. And a baseline would be a previous version, maybe the state of production, maybe a golden copy of production. Something that would give us the reference to whatever else is out there. And let's try and understand, the matrix that we see here. So if there's no difference between the environment, of course, there's nothing to do. But if there is a change, and again, let's shorten the process. Let's say it's directly going from development to production. If there is a change here on development, how do I know that it was change in development? Because development is different than the previous version of development. So I now know that there is a change coming from development. But at the same time, my production is exactly as the previous label was. So it's clear to understand that we have a change coming from development with no conflicting change on production. We should take it forward. We should deploy that change. If development has not changed, but what did change is our target environment. If that's production, that might be a hotfix. The last thing you want to do is override that with an older revision. That's an out-of-date revision. Okay? We don't want to do that. And of course, if we have changes coming from development, conflicting with, maybe hotfix would not be the most common scenario. Just think about back to those several branches of development where you have team A, team B, and team C working in parallel. One was issuing a change to a procedure. It's now in integration. I don't know, additional function or whatever. And the other team now has some interface changes. And when they're going to push that script forward, they're going to override the first team's changes. That's a conflict. This is something that we need to be aware of. This is something that needs to be merged because there's no right or wrong. That you can't take that version or this version. You need to take them both. So how would something like that look? For anybody who's familiar with code, that's not new. You would just see an additional baseline to that comparison. So if you had that index as part of the previous release, now you understand that you still have it on production. And the change is it was dropped from this development process because development used to have the index, now it doesn't. This is something we need to deploy. If we didn't have that index as part of the previous release, and we still don't have it on development, that's clear to understand that the change was to production or to our integration environment, and the last thing we want to do is revert it, and we would just ignore it, okay? And talking about merge, I'm showing you this 10-liner. Nobody would have a chance to know where the conflict is. Because in order to identify conflicts, you need to be very familiarized with the code. And if it's not all you're doing, if you didn't do everything from A to Z by yourself, there's no way for you to know it. Because essentially, part of that change is coming from the target environment. Okay? All I know is that some of the, in this case, an hour was changed, the date was changed, and exclamation marks were added. But part of that change was due to something that was deployed to the integration environment. And in order to merge them, you need to take all of them into account. You need to take these changes from the source, these changes from the target, and you know that by analyzing the baseline as well. So a three-way analysis would enable you to identify conflicts and to implement merges. Okay? So If you do that for code, why not do the same for content, metadata content? Why not do metadata content versioning? Why not do metadata three-way analysis and identify which changes are coming from production and which changes are coming from development, which should be pushed forward and which shouldn't be overridden, okay? So essentially, by making sure that we do a three-way analysis and not a simple two-way, we eliminate the risk of taking decisions, okay? This concept would enable us to really take confidence in what needs to be deployed. And when we gain confidence, then we can start trusting the process. We can start automating it. Then I was talking about red flags. What red flags? Okay, we have a build process now. Okay, it's not just moving this specific version to testing and looking at the result and moving it to UAT or production. We have an automated build process, continuous integration, continuous delivery. That means that we have tools that are doing everything automatically. This example is Jenkins, if anybody heard about that tool. That's a very common open source solution for doing builds for code. But there's no reason why that can't work with a database. If you implement a three-way analysis and identify that there's no risk, what is no risk? Either you take the changes that you should, you ignore the changes that would override something that it's clear that it shouldn't, and you can stop with that red flag when you see a conflict. That would be a good enough reason to stop the process and evaluate what went wrong. Okay? Two teams pushing something into the same environment. Wait. Same happens for code. When you do that for code, it's going on at the check-in process, because that's the way code works. Database doesn't have a traditional check-in process because the source itself is in each revision of the database, in each environment, essentially, in each branch, you can say. So when changing the database, you need to have the same process. So pushing changes to the integration environment, getting the red flag that something is conflicting, you stop the process, somebody looks at the results, evaluates how that conflict needs to be resolved, makes the decision, and let the process continue. So, safety net for deployment automation. Is that me? Sorry. First thing is to gain confidence that our version control process is accurately and safely and trusted part of the process. If we can't trust the building blocks, everything else that we've been discussing just doesn't cut it, because we can't be sure that the changes are actually implemented. When we implement task-based development as part of that version control process, we can first of all have a lot of information. Who's doing what, when, and why. That why process is very important. To some companies, that's the only reason to implement a good process, because they need to comply, they need to do audit reports. Okay, so that why is very important. We need to be able to run that as a batch process, because everything is going into automation side of things. Everything is going into continuous integration and continuous delivery. And we can't really separate the database from the code, because we need to ship them together. So everything that I just said needs to be correlated with the code. So doing a whole build, not just a database build, but a code plus database build would enable us to synchronize our database changes with the application changes that go hand in hand. I have a new column, maybe I have a new logic in the application to back that up. Okay, so everything needs to be tightly grouped together. And of course, we need to be able to identify conflicts. First of all, in order not to break stuff. And secondly, to be able to merge them together and be able to look at the whole process through a much safer point of view. So I would say that being able to stop the line, okay, so that charcoal line that we saw before, being able to stop it when something goes wrong should be able to happen automatically. Okay, you can't have a manual inspection for changes. It wouldn't cut it going forward. You can't do stuff, just create scripts and saying, I'll deal with it. We've dealt with it until now, but because everything is speeding up. Maybe you're dealing with it now, 6 months from now, it might be different. A year from now, might be very different, okay? So being able to have safe version control, trustworthy deployment decision, and being able to stop the lines, I think these are the most important things that you need to have in mind while thinking about continuous delivery and your database. And essentially, in order to really support the process, we can't just deal with, of course, just application. And it's not just database. It's everything. So if you look at what's happening out there in the market, you see configuration tools pushing the whole configuration for the operating system, for the database, for patches, for schema changes, and for your code. Everything needs to be managed. Everything needs to be tested. Okay, you can't have something running a full process where it's built properly, tested automatically, and provided to the next environment, while you have some side process working manually and not going through these processes. That's the message. I'll be happy to take your questions.